down on B, up on red, or ground. All right, that's it. Weight is done. And again, if you did weight of the rope, I would do the sloppy IGN for ignore. Assume ideal rope. All right, normal force. All right, I'm going to ask a question. Don't want you answering quite yet. But the question I want you to think about is how many normal force pairs are there? So think about the answer for a moment. How many normal force pairs are there? The answer is the answer. Right. How many normal force pairs are there?
3.
Yes, there are 3. Give me one of them. Somebody.
Box A touching the ground.
Between A and the ground?
A.
Yeah. Ground being ramp in this particular part. And which direction is it acting on A? All right, so a couple, when you said up just then, were you thinking that way or at an angle? Yeah. So up and to the left. I got y sub A here, and then y sub A here. There's one pair.
And then up and to the right for B. On
Okay.
B.
And then the third pair.
The pulley.
Yeah, pulley and rope. I'll just do R. Normal force none. Tensions.
It would be the rope and box B.
In the rope and box B, okay. So pulls on the rope, so I have a tension here, tension here. And
Same thing for A.
And if you want to do subscripts, then you would have, these two would have the same subscript, and those two would have the same subscript, but not necessary for an ideal rope. Probably the biggest mistake I see with people doing tension is, actually there's 2 big mistakes. The one mistake is putting tensions in the middle. Yeah, there's tension in the middle, but if I have a tension acting this way at that point, I have another tension acting this way at that point from the other half of the rope. So they cancel each other out. Those are known as internal forces, and we are ignoring them. If you do not wish to ignore internal forces, you're on the path to madness. Yeah, one.
Just had a question about the symbols and the subscripts.
Okay.
So for like total force, for weight, we're doing, they all have prescribed symbols, and then we put like box A as the subscript.
Right.
But for tension, you put the symbol and then T for tension. So could we put like the symbol and then A?
Yeah, if I did I would have like a subscript if I did that. And the reason is that I use capital T for period later on, and tension and period will sort of show up together. And I just, instead of using capital T for tension in my force diagram, and then later on going, okay, we're now going to ignore that, capital T is going to be something completely different. And we'll use this symbol for tension. I find it easier just to start now with F sub T.
Okay.
If you wish to use capital, on the first test, if you're using capital T, I know what you mean. Just recognize that will change.
I just meant like, instead of FT, if we put FA.
No, I need to somehow know that it's tension.
Okay, well I thought, isn't F the symbol for tension?
F sub T is the symbol for tension.
Oh, okay.
If you want to use your own symbol, just, if it's not something that I can look at and go, okay, I know what he's talking about, just do a little legend off to the side. I'm gonna use Q for tension, or whatever you use. See. Didn't know if you had a question or just work. Looks like Julie's just working out for herself.
What?
I didn't know if you were about to ask a question or not.
No, I'm starting to get it, so I'm happy.
All right, excellent. Tension done. Now friction. Which way is it going? Which way does it want to move?
The box A wants to move down and to the left. Or
Yeah, A wants to move down, so the friction is gonna go,
If A wants to move down that way, friction would be acting that way on A. Why do you say A wants to move down?
it's a little random.
yeah.
But then box it kind of stops it from moving.
If it were frictionless, it's got one of two choices. It's an ideal route, so it's not like they're both gonna go down the ramp. So it's either gonna go like this, or it's gonna go like that.
We don't know which
So,
direction it's going.
Yeah. I did not give you enough information.
Yeah.
Which is why I want to do frictionless, because it really, direction of friction really does depend upon whether the force down the ramp from A is bigger than the force down the ramp from B. Which one is going to win in that tug of war, in a sense? So, on a problem like this, in 151, you should be able to calculate it. It's 110, you don't need to calculate it. In 110, I need to tell you. Now, if you want to learn how to calculate it, it involves trig. Just to give a little teaser there, so I'd be glad to explain after, outside of class, if you wish. But for the sake of this, since I heard A going that way, why don't we just assume that is the direction it's going to move? We'll be there for an indicator, actually. That symbol will make more sense later. So I'm indicating that it wants to move that way. If that's the case, which way is friction acting on A? So
The opposite
couple fingers
direction.
pointing in the right direction there. That's friction on A. The other part of that pair?
On the ramp
Okay.
down.
And then on B, which way is friction gonna act?
Down. I'm sorry. Down
If
to the
if
right.
if A is gonna be moving this way and B is moving that way, then friction has to be acting that way on B.
Yeah.
It's not in a vacuum. We can't go, well, B wants to go down the ramp. Don't forget, we have this tension pulling up on it, so which way B wants to go is affected by which way A is gonna go. And then, that way.
And this would be if you gave us more information, or?
If I told you this, then we can determine it. If I did not tell you, let's say it's a test, and both interpretation, I give you this problem, and I don't tell you which way it's gonna go, and you don't ask, and I don't write it on the board, what happens? If there's multiple interpretations, then I have to accept both answers. As long as, it's either gonna go like that, or it's gonna go like that, as long as you're consistent.
But we pick it.
If I did not give you more information. There are times when I'm grading this problem and I'm, marking, I have my solution, I'm marking through it, and then at some point I go, oh, wait a second. Yeah, I guess it could have gone like that. And then I go back through all the ones I've graded so far and just give back credit where I needed to. Or if I hand it back to you, and you come up and make an argument. Occasionally students will say, wait a second, then what about this? And then occasionally I'll go, oh, yeah, you're right, I didn't see it that way. All right, we're about to do a test level problem. Any questions before we do the test level problem? Yes, Leslie?
what was the name for that one?
The name for that one? I called it double ramp.
we gonna do an example with O?
On the test level force diagram problem, I'm trying to think if I've ever done it though in there.
Oh,
We'll do problems with O in it,
Mhm.
especially in chapter 4.
okay.
Alright, give me a moment to draw it out. No, I don't want to do that one. The sun is not strapped to the snowboard, by the way. I do need to give you one other piece of information. They are accelerating to the right. They are moving to the right and accelerating to the right. As you will later discover, that means they are speeding up. All right, so the objects. Now, you know, parent pulling child on snowboard is the problem. I did dad and son just because when I first wrote this problem, my daughter would have fallen flat on her face if I'd done this. My son might have also, but more apt to stand up. All right, so I would set up the scenario. It's an ideal rope. I would give you bits of information such as they're accelerating to the right. That I'll explain why that's important later. And then on the next page, so generally I've got the paragraph explaining the situation. I'll have this drawing, and then on the next page, I'll have it broken down into parts so that you know what goes with what. So we have dad. Rope, sun, snowboard, ground. Now, on the test level problem, I don't know how many this is going to be off the top of my head, but I think the most I've had is 42 forces. In other words, 21 pairs. And the least, probably somewhere around 30 forces. But the next to the last problem will be something of this caliber. It will not be this problem. All right, so what can we eliminate starting off?
O.
Right. Tell me a force acting on what object?
The weight of the sun on the snowboard.
How am I drawing my arrow?
sun down on snowboard, snowboard up on sun.
So weight is repelling the boy from the sled,
No. On the ground.
so the boy's being repelled. So there's weight X which way on the smaller object? Yeah, the planet is pulling everything, it's
Down.
pulling all the stuff down, so it's gonna be down on the boy. So I got weight on boy. Or sun, let's see. No, whatever subscription is. Consistent. All right, so where's the other part of that pair?
Oh,
The
on
ground.
the ground.
All right, one pair done.
So the same for the father.
Good.
Wouldn't there be
Snowboard.
weight from the snowboard? Wouldn't the ground be pulling it down?
Yes, indeed. So, weight of, I'll do S for that. Rope is ideal, it's massless, no weight, therefore no weight. We're done with weight. All right, what's another force action on what object?
Friction.
Let's say friction till the end.
Okay.
What'd you say? I heard something else. I thought, no acting on what, which way?
The snowboard, the ground, the earth,
Which way is it acting on the snowboard?
so it's the surface of contact is gonna be up, down.
Okay, so is it acting up or down on the snowboard? You're doing this, the pair here.
Arrow up on the snowboard.
Okay. So the ground's pushing up on the snowboard, Y says S, and then snowboard's pushing down on the ground. Right, what else?
Same for the child,
And
the boy, and the ground. No,
is he touching the ground?
no, he's touching the snowboard.
Yeah. So it's up on the boy, down on the snowboard. And any others?
The father.
Up on the dad. Dad's pushing down. Anything else touching besides the road? All right, I want to say friction till the end, tension.
So,
At the end of the rope to the child. To the boy,
All right, so which way is it acting on what?
to the left. Like
On
arrow
the,
pointing, arrow pointing left on the rope,
that way?
yes. No,
Close.
because he's pulling this way, so it'd be this way.
It's along the lines of the rope.
Yes,
So it's
Yeah.
left and a little bit down.
yes.
Y sub D, and then that would be in the opposite direction. Y sub D.
But we're doing tension now, right?
Pardon? Oh, sorry, that is tension, not normal force. One rope ideal, so I can just do F. Okay. Thank you.
Yep.
so. For the tension for dad's end.
Okay. here, which way does this arrow point for the dad?
Same way.
You pointed that way?
No, down and to the left.
Down that way.
Yeah.
They are in opposite directions. This is another one of the most common mistakes I see. This is just a way of displaying the arrows. Some people will know that, oh, it's between the hands and the rope, and they'll point the arrow up towards the rope. And that's not the case. The force is pulling this way on the dad. One rope, I've gotten taken care of both ends, that's done. So now, friction. If the ground is frictionless, where the snowboard is, which way is the snowboard going to move?
To the right.
Therefore, which way is friction acting on the snowboard? All right, so friction's acting this way on the board. And where's the other part of that pair?
To the right on the ground.
Yes. I do recognize that if you're doing this on a test and you don't have multicolored pencils, there are some floating around here. And you're doing it all, sometimes it gets a little bit cluttered about which label goes with which force. I just try to be clear. I do my best to try to interpret what you have drawn.
Are you allowed to use multicolor?
Yeah.
Oh, if you have it,
Yeah.
okay.
And yeah, the biggest issue I found, and it's not a big issue, but the biggest one that I have found is that the student gets confused, draws the arrow, but never labels it. So just, if you can keep it straight in your mind, I'll do my best to interpret. All right, what about between, again, wherever there's a normal force pair, there could be a friction pair. So